All right, everybody, hello and welcome to our next topic, which is the scientific method. All right, you might be thinking, I already know what the scientific method is, and you might be right. You might understand the scientific method to a degree, but we're going to talk about it more in its practical sense, its practical application, and things you have maybe not quite considered about the scientific method. We're also going to use this as a refresher for hypotheses. Hypotheses are important, they're integral to the scientific method, and we will be formulating our own hypotheses in this class. So we ought to talk about them. So before we get into the scientific method or hypotheses, we'll first talk about aims of a study. This is a general term that we use to describe what research is intending to contribute. So this is different from a hypothesis. A hypothesis has a specific scientific purpose. Aims are more a way of generally explaining what the goal of some research is. So aims are a clear statement about what the research intends to contribute and justifies why the research is being carried out. All research should have clear objectives, even if the objective is just to explore some idea, right? We talked a little bit about dreams in a previous lecture. Maybe you are just aiming to explore dreams, right? Explore why dreams happen, or just some facet of dreams. It doesn't mean your aim needs to be so clear-cut that you're going to determine the cause of dreams. Aims have a different role than hypotheses. And they communicate what a study will provide to the field, the general population, or to some specific field like education or business. So why are aims important? They're important because you often need money in order to do research. It's not always cheap, right? Take something like MRI. I've done some work in MRI. It costs thousands of dollars to run an MRI every day. It's very expensive. So to use a piece of equipment like that, you often need money or funding from people who write grants, like government institutions. So your aim should be clear, right? Your study should seem worth doing, especially if it's going to cost you some money. But we'll give some examples of studies that are not quite so serious. All right. So on to hypotheses. So this shouldn't be your first time hearing about hypotheses, as you've taken statistics. So what is a hypothesis? It's a statement that serves as a basis for further investigation. So a hypothesis is not a question. It's a prediction, it's a statement, and it needs to be justified. There should be a reason why you formulated a certain hypothesis, and it will generally be because previous research has led you to have a specific prediction. So aims tell us why it's important to test the hypothesis and what basis or rationale there is for them. So they are related, but hypotheses are our real scientific piece, right? What goes into our actual research report. Okay, so we have two types of hypotheses, right? We have null hypotheses and alternative hypotheses. So if we can remember way back to statistics, we set up these two hypotheses so that we have mathematical opposites to each other. So when we run a statistical test, only one of these two hypotheses can be supported. We use probability to do so. We will do a statistics refresher in the course. So if you're feeling a little bit like this feels like unknown to you, do not worry. We will continue to talk about these topics. But at a very base level, null hypotheses suggest that there is no significant difference, no statistical difference between the variables in your hypothesis. The alternative suggests that there is a difference or there is a relationship. And remember that the alternative hypothesis is harder to support because statistically or probabilistically, whatever we set our alpha value to or our p-value, hopefully some of this is coming back to us, that indicates our critical value and what we would need to find in order to reject our null hypothesis. So our null hypothesis is a sort of baseline. It's innocent until proven guilty. And the research hypothesis is often what we want to address or what we want to answer. And we need to find a certain level of confidence in order to support that alternative hypothesis. So again, we'll get to all of this. We'll continue to talk about this, but hopefully we remember at least a little bit about this mechanism of hypothesis testing and why we use these two different types of hypotheses. All right, other different types of hypotheses we can have. We can have directional hypotheses. We can say that we expect a positive relationship between two things, or a negative relationship between two things, or that one group is going to score lower than another group on a certain measure. We can have direction to our hypotheses. So instead of just saying that there is a relationship, we can say that there's a relationship with a certain direction, right? So maybe we think that more screen time equals less, more, let's say, leisure screen time, like watching TV and social media. More leisure screen time leads to a reduction in academic performance, right? That's a negative relationship. We could say that between men and women, we expect women to have more anxiety symptoms, right? That would be a specific and directional hypothesis. So here's some examples. All right, I give a couple examples here. And examples of ways that we can say hypotheses differently. There's no just complete template for a hypothesis, but we want to think about if we're including a direction or not. So here we have higher levels of attitude similarity lead to higher levels of attraction, all right? Do we think this is true? I think this is true, right? I think social psychologists would say that this hypothesis has some support. So examples of a null hypothesis here would be that there's no relationship between the two, whereas the alternative would be that there is a relationship between the two. All right, let's take a look at another. Okay, more time around my dog leads to higher levels of happiness. Okay, I know from anecdotal experience, all right, I know that that's true for me, right? Using the word true loosely here. But I could make hypotheses here. I could say people who spend more time around my dog will be happier than people who spend less time around my dog. I can say exposure to my dog is positively linked with happiness. This goes back to aims of the study, right? The aim of this study would only be to fortify the feelings I have for my dog. It'd be difficult to get someone on board to say fund this study if it required funding, but no less, it's an example of a hypothesis, right? A prediction that we're making, and if we want to add a direction or a specific prediction to our hypothesis. So here's what I think is a helpful chart. I got to get my big head out of the way here. A helpful chart to take a look at directional and non-directional hypotheses, and also a hypothesis that attributes cause or not. All right, so if we take a look at a few of these examples, we have directional hypotheses that are causal. We could say more of A causes more of B, or non-causal, we would say more A is related to more B. All right, so this is back to what we talked about before with the different types of studies. If you want to have a causal hypothesis, you need to run an experiment. And then we have non-directional hypotheses here as well. So I think that this is helpful, right? There are lots of different hypotheses that we can have. So when we formulate our own hypotheses, this slide might be of good reference to you. All right, move my big head again. All right, so hypotheses in research, why do we use them? We use them because they inform us, right? They're helpful. They guide our science. They guide our questioning. So research can attempt to test a hypothesis, which it often does. It can attempt to explore hypotheses. Maybe we don't even know what type of prediction we want to make yet, but we just want to explore our options. And research can also attempt to generate more hypotheses or more predictions, which it often does. And it often does because our scientific method is a circle, all right? Scientific method. So again, you've maybe heard of the scientific method, but I want to draw your attention to a few things about the scientific method that we maybe haven't thought about. The scientific method is often presented as a set of steps, right? There's usually something like 6, 7 steps. And then it's done, right? They say you do steps 1 through 6, and then that's science, right? But in the grander scheme, the scientific method never really stops. The scientific process never stops or ends. According to the scientific method, we can always expand our knowledge on any given topic. So this is what we do, right? We would generally start at the top with an observation, come up with a question that we want to address, come up with a prediction for that question. We would run an experiment or a study. We would do some analysis, and then we would come to conclusions about our particular study. So oftentimes this is where the scientific method will sort of end when it's presented in textbooks. But the reality is, as soon as you make a conclusion, the idea is that other researchers in the field will grab onto your conclusions and continue to expand them. We'll talk about a research report, or how we write a research report in this class. And one of the last things that a research report talks about is the limitations of a study, what could have been done better. So other scientists in the field will likely pick up where you left off, or you'll pick up where you left off and start the process all over again. So I like to point this out. We don't spend a lot of time talking about each of these steps of the scientific method because it's something that I think has been driven into us usually at a young age. But we do talk about it because it has greater implications here and now in this class. So when we do our own research projects, we will follow this exactly. You'll have a question based on some observations that you've made or information that you've gathered. Then you'll come up with a hypothesis. You'll run a study and do some analysis and then draw some conclusions. So we'll see this process in full. All right, so this is something kind of funny that I like to talk about in this class. This is called the 8 Circles of Scientific Hell. This is about what we can do wrong, right? What we can do to interrupt the scientific method and the scientific process. So I'll just talk about each of these kind of generally, just so you can see where we face issues in the scientific process. So we talked a bit before about published research, right? Meaning that it's been peer-reviewed and deemed good. So, all right, we got limbo up top, meaning that the science hasn't been published yet. All right, and then next we have overselling, which is basically coming to a conclusion and then telling people it's the most exciting conclusion that has ever been found in all of science, right? And this seems ridiculous, but people do it all the time, right? And you'll see headlines and news stories about research where we've found the cure to this, right? When we come to find out that it's not really the cure, right? It's just a step on the way to the cure of whatever is trying to be cured. Next, we have post hoc storytelling. Post hoc, again, something that probably was touched on in your statistics class, but post hoc testing is basically testing after your original hypothesis test. So some statistics have built-in sort of post hoc analysis, like an ANOVA, where you're comparing multiple groups. That would be your initial analysis. Then you do a post hoc test to find specific groups, specific group differences. But what this is really referring to is after going through the scientific method, after getting to your conclusion of your initial hypothesis, is basically digging for something else in a different story, basically, than what you originally had set out to find. All right, then we have p-value fishing. We'll talk more in the class about things like family-wise error rate, and that the more tests you run, the more likely you are to find significance. And that's what this is referring to here, is basically running lots and lots of tests until you find a significant relationship, but not basing it in any type of question, hypothesis, right? Just digging for a conclusion. Creative outliers means basically throwing data out that maybe shouldn't be thrown out. This is relatively common. Plagiarism, we'll just leave that at that, right? We know that plagiarism's bad. It happens even in the highest zones of science, right? Plagiarism is always a problem. Don't you dare plagiarize in this class. We will find you. All right, non-publication. This is a big and interesting issue as well, which is that scientific journals want to publish what is exciting. They want to find articles or reports that report on interesting findings. If you carry out a study, maybe you work on it for years and you don't find anything that is exciting, right? Or anything that people might want to know about, right? Maybe all of your hypotheses are not supported and you don't have anything necessarily new to share with the field. But the catch here is that even if you don't have anything necessarily new to share, if you share it, you'll save others from wasting that same time. So this is a bit of a global issue here where research journals will turn away sort of unexciting findings, even though those findings are important to have out in the world. So again, we'll talk a little bit more about that whole mechanism as we go. Partial publication, same idea here, that you leave out some pieces of your research that would be informative to others. And then the very bottom, the pit, the bottom of hell is inventing data, which also happens. People making up data to support claims that they want to support. And this is why the peer review process is so important and why replication is so important, right? If somebody makes up some data and someone else tries to repeat the study and can't replicate the same result, then we might know that something was wrong with the data to begin with. So I know that's a little bit of a lot, and you might be thinking to yourself, we kind of talk about the shortcomings of science a lot in this class, right? A lot of it seems very doom and gloom and everything that can go wrong. But knowing what can go wrong and knowing what can be done poorly or what can be done unethically is how you find the good, right? Is being aware of how it can be done poorly or the wrong way. All right, so now we're talking about something called the hypothetico-deductive method. This is really another word for the scientific method, but we're using deduction based on hypotheses. So we'll take our hypotheses, whether they were supported or not, and then decide where to go from there in our line of research. So from what has been observed, hypotheses are proposed. Ideally, we use methods that would disconfirm or could disconfirm your hypothesis. And then we test and retest and reformulate hypotheses. So this is basically saying that the anchor of the scientific method is the hypothesis, right? Whether or not the hypothesis is supported or not will inform what the researcher should do next. So that's what we're saying here, is that we should look for instances where the hypothesis fails, where our predictions are wrong. Then we can develop hypotheses that are based on that information. Something else to note here, we're going to come up with a hypothesis, all right? I've said that a couple of times here, but we're going to come up with a hypothesis based on some research that we read, right? We're not just going to go based on some hunch that we have, though oftentimes a hunch can inform your search for certain research, right? Maybe you have a hunch that people that engage in more online dating also have higher sociability, right? Maybe that's something that you think. You would go look up to see if anyone has confirmed or denied that particular hypothesis, and then you would formulate a specific hypothesis. So again, this hypothetico-deductive method, it sounds a little complicated, but it's really just saying that we base our scientific method on looking for hypotheses, basing it around where hypotheses fail and when they succeed. And then just a little funny for you, something funny, right? Examples of funny hypotheses, they're digging. This person's digging for someone to come up with funny hypotheses for them, and then someone comes up with a hypothesis that they're not capable of producing their own work. So, funny. But we should keep all these ideas in our head because, again, we will make our own hypothesis and we want to make a good one, right? We don't want to make a hypothesis that we already know is going to be supported. We also don't want to come up with a hypothesis that is doomed to fail. We want to come up with a hypothesis that is well informed by the research that is already out there. So that's our bit on hypotheses and the scientific method. Please let me know if you have any questions on this, and I'll see you next time.